A bumblebee can see something no human has ever seen. It is not a color. It is not a scent. It is electricity. Every flower on Earth broadcasts a silent electrical signal. Bumblebees read it like a billboard. This is not speculation. This is peer-reviewed science published in Science and PNAS. The discovery came in 2013 when researchers at the University of Bristol found that bumblebees can detect the electric fields surrounding flowers. Here is how it works. When a bumblebee flies through the air, friction strips electrons from its body. The bee builds up a strong positive charge as it moves. Meanwhile, flowers carry a natural negative charge pulled from the ground beneath them. Opposites attract. The flower electric field bends toward the approaching bee. The bee body is covered with thousands of microscopic mechanosensory hairs. These hairs are so sensitive they can detect the shape and strength of the electric field around each petal. The hairs physically move in response to the electrical force. This is how the bee reads the signal. Not with eyes. With touch. Here is the part that changes everything. When a bumblebee lands on a flower to feed, some of its positive charge transfers directly into the flower. The flower electrical charge changes, and it stays altered for 1 to 2 minutes. That is a signal to every other bee in the area. A second bumblebee approaching does not need to land. It reads the altered charge from a distance and knows the flower was recently visited. The flower is marked. Nectar is already drained. The second bee moves on without wasting a single calorie of energy. This is efficiency evolved over millions of years. This is not a replacement for scent and color. It is an extra layer. A backup system. An invisible layer of communication happening in every garden, every meadow, every field on Earth. The 2013 study by Clark, Whitney, Sutton, and Robert demonstrated that bumblebees can learn to distinguish between flowers with different electric fields. A follow-up study in PNAS in 2016 identified the mechanosensory hairs as the actual detectors. Sutton and his team showed that these hairs respond to electric fields at intensities as low as 35 volts per meter. That is comparable to the fields flowers naturally produce. Think about what this means. Flowers are not passive. They are signaling in a language we cannot perceive. Bumblebees evolved thousands of microscopic antennae just to read this signal. A signal that has been flying past our faces every time we walk through a garden. What else is out there, invisible, waiting for us to build the right sensor? If a flower can leave an invisible warning sign, what else in nature is talking right in front of us in a language we cannot hear? Comment your theory. Follow Animal Impact for more mind-blowing discoveries. Like and comment below. We will see you in the next one.